everyone, hope you all are doing good. So you will get all the solutions in the Telegram group, and the link is given in the description, and you will also find the link in the comment section. So do join it to get the solutions in C++ as well as in Java. Now let's start today's video. So today's GFG POTD is about two repeated elements. Now let's jump into the problem. So what does the problem states? It states that there are elements in the array which are in the range 1 to n, and there are two extra elements in the array which are repeated, and you need to find out that, return that. So after returning, you will get this as your output, because 1 and 3 are the only elements that are repeated. So let's think of the ways we can solve this problem first. So the first approach would be to sort this particular array and then count the elements. If the elements are matching, then we will return that element. So if we sort this, what do we get? We will get this as our array. So, is it matching? Yes, it is matching. So, return 1. Is it matching? No. Is it matching? No. Is it matching? Yes, it is matching. So, return 3. Is it matching? No. So, you will return these two elements. But there is a problem. Now, if you sort this element, this array, what you will get? You will get 1, 1, 2, 2. But here you can see the output is 2, 1. So if you return the elements, then you will have to return 1 and 2, because you will find the 1 as the matching first, and then you will find the 2. But here we are told that return the numbers in the order of appearing twice. So this approach is not the best approach. Now moving to the next solution. So our another solution can be to store the frequency of each element in the map data structure, and then the number which are appearing twice, we will just return those, right? So there is another problem. If we use this map data structure, what is the problem? It is the extra space that we are using. We have been mentioned here that we can only use big of one space. So this won't work because map data structure occupies extra space. Now moving to the next approach, which will be a suitable approach. So in this approach, we will use negation method. Now what it is? So we will use the negative sign to mark whether an element has been encountered or not. So let's see how to do this. So to do this, we will require a variable called index, which will store the index, and a pointer I, which will start from 0 till n plus 1, right? So what is the element at index 0? It is 1. So you will store this element at our index. Now move to this index. So where is this index? It is here. What is the element at index? It is 2. Is it greater than 0 or less than 0? It is greater than 0. So make it negative. Now our I will point to this. I will become 1. So we will store this element as our index. So let's update this. Now it is minus 2. But we need to remember one thing, that index can never be negative. So we need to store the absolute value. So you will update this to absolute of minus 2, which will be 2. So now point to index 2, that is here. What is the element at index 2? It is 1. Is it greater than or less than 0? It is greater than 0. Then what to do? Make it negative. Now our I will increment to 2. So it will point here. Now what is the element here? At I equals to 2, it is minus 1. Again, we will update the index to 1. Why? Because minus 1, it is minus 1 and we can't store the index as negative. So we have to take the absolute value, which will result in 1. Now move to this index 1, because our index is now pointing to 1. So what is the element here? It is minus 2. Since here is a negative sign, so that means it has been encountered once. So what does that means? It has been visited by someone or the other. So who is that someone? It is our index. It is our index. So return that index. Now our I will point to 3. It will increment to 3. We will store this element as our index now. Updated. Now move to this index equals to 3. So what is the element here? The element here is also 3. Is it greater than or less than 0? It is greater than 0. So make it negative. Now our I will point to 4. It will increment to 4. Now what is the element? It is 4. So store this as our index. Now our index also points here. So is it greater than or less than 0? It is greater than 0 again. So what you will do? You will make it negative. Now our I will point to 5. So what is the element here? It is 3. So store it in our index. Update our index to 3. Now our index will point to 3. What is the element here? Is it positive or negative? Is it greater than or less than 0? It is less than 0 because there is a negative sign. And if there is a negative sign, what does that mean? It has been visited once by someone. And who is that someone? It is our index. So this is our index. We will return 3. So this is our output. See, this is our output. So now let's implement the code. So we will take a vector and now start a loop I less than n plus 1 I plus plus, and we will take a variable called index. What we will store? We will store the absolute value because index can never be negative. Now we will check the conditions. If my array at this index is less than 0, then what to do? We will push this answer because this has been visited by someone, and who is that someone? That someone is our index. Now if the array at this index is greater than 0, what does that mean? It has not been visited by anyone till now, so make it negative. And at last return ans. So let's compile and run. So compilation completed. Now let's submit. So the problem has been solved successfully. I think we can end the video here, but before that, do subscribe the channel to get similar content, as gaining a subscriber and a like in my videos does motivates me a lot to be consistent and creates more such content. So do subscribe, like and share with your friends. If you have any doubt, you can ask me in the comment section. Thanks a lot for watching. See you guys again tomorrow.